forms of energy. So as we discussed in the Nature of Energy video, mechanical energy, thermal energy, nuclear energy, chemical energy, radiant energy, and electrical energy are all different forms of energy that exist. We'll start with talking about mechanical energy. So the mechanical energy is just the energy of movement. It includes both the potential, that should say stored, and the kinetic of motion energy. So it has both of them in it. Okay, so mechanical energy includes both the potential or stored energy and the kinetic, the energy of motion in it. So when we talk about mechanical energy, we talk, let's say, about a football playing a ball or throwing a ball. The mechanical energy is going to be the addition of the, let's say, potential, the gravitational potential energy, as well as the kinetic energy, the actual energy that's being used for the movement of that football. Chemical energy is stored in fuel and can be released by a chemical reaction. So when we break stuff down, let's say when we eat stuff, a lot of you guys were talking about yesterday, well, energy is like food that we eat. We get energy from our food. Well, that's true because the energy is stored in the molecules in the food. And when we break them down in our stomach, we break those chemical bonds and we're able to use that energy to power our body. It can also be released outside of it via chemical reaction. We do chemical reactions in our body, but another example is the chemical reaction that occurs when a match is lit and then you burn off the chemicals, okay, and that breaks the bonds in the chemicals that are on that matchstick, and then the energy is released as light and heat. So chemical energy. Thermal energy, this is the energy of moving particles in a substance. The thermal energy is like what we talked about with heat when we are talking about heat energy, and the heat is a measure of how, a temperature is a measure of how fast molecules are moving. Well, heat energy, remember, is just a specific type of energy. It's a thermal energy, and it determines how active atoms are. So the faster they're moving, the warmer it feels for us, and the slower they're moving, the colder it feels for us. So remember, the excited hot atoms are the ones that are moving super fast, and the laid back or cool atoms are the ones that are moving kind of slow. Radiant energy, this is the form of energy that travels in waves, and we're going to talk about waves next unit, but it travels in waves, and it can move through empty space where there's no air. We can see this type of energy, so it is both visual, okay? It is visual and it is made of waves. So those waves travel through empty space really well. So that's how we get all that light and or that light energy from the sun. Okay, it's radiant energy. There's also radiant energy in this flame, right? Because it's releasing light. It's also releasing thermal energy. So nuclear energy. This is energy stored within the nucleus of an atom, and this is one of those things that if we split the nucleus of an atom, okay, let's say into split a uranium into beryllium and krypton, we get a huge release of energy because energy is stored in that nucleus of that atom. Electrical energy. Electrical energy is the form of energy that's produced when electrons move from one place to another, and that's what electricity is the movement of electrons, electrical. So when those electrons move from one place to another, we get electrical energy. All right, so let's talk about this really quick. Okay, we have electrical energy is transported to your house through power lines. Remember, that's electrons moving from the grid where the power is produced to your electrical outlets. When you plug an electric fan to a power outlet, electrical energy is transformed into what type of energy? So I want you to think of a fan, think of all the things that it does, and I want you to determine what type of energy that we already discussed is produced or is transformed into when the electric energy enters this fan. So go ahead and pause it and write that answer down. Okay. So the answer is mechanical energy, the energy of movement. These fan blades actually start moving around because of the electrical energy. So that electrical energy is transformed into mechanical energy. All right, what transformation occurs when an electric lamp is turned on? So we have the electricity coming into your plugs. We plug in this lamp and we turn it on. Go ahead and pause it. What type of energy is it transformed? Is the electrical energy transformed into? Radiant energy. Radiant energy is the energy of light, so any light that you can see. You could also say that it is transformed, depending on if the lamp gets hot, into thermal energy as well, because certain light bulbs will get very hot to the touch. So it could be transformed into radiant energy and thermal energy. So what types of energy are shown below? So what type of energy is shown right here? Okay, go ahead and pause it and write down your answer. All right, this is mechanical energy. And then if you've ever dragged something across the floor, you might notice that the friction causes stuff to get hot, and that's the release of thermal energy. So mechanical and thermal energy is actually the types of energy that are going to be shown below. What type of energy is shown in this picture? So that's coal. So think of the type of energy that's going to be shown there and there. So go ahead and pause it and write down your answer. It is chemical energy, because there are bonds, there are atoms and molecules in here that when broken down will release energy. Same thing in here. There are bonds and things that when broken down will release energy. That's how batteries work. What type of energy is shown there? Well, that is a nuclear power plant, so obviously it's going to be nuclear energy, the splitting of atoms in order to produce large amounts of energy. What types of energy are shown there when we turn on or off or change the channel in our TV? Go ahead and pause it, write down what you think. So electrical energy, because we have electricity flowing into the TV is giving off light, so radiant energy. And mechanical energy, because we are moving our finger from one button to another. So those are the three that you will get in that picture. What type of energy is shown in a tomato? Or in cotton candy? Well, if you think about it, those are food, that's fuel for us, so that must be chemical energy. Okay, so all the food that we eat is chemical energy that will be transferred into, well, our body's kept pretty warm, so probably thermal energy to keep our body warm, as well as some mechanical energy to make sure that we can move, and those kinds of things. So those are the reactions or the transformations of energy we are getting in our body. So what type of energy is shown by a stove? Well, it's thermal energy. It's also it's not necessarily giving off light, but you might see it as light. So you might have some thermal energy and some radiant energy. So I want you to draw a flow map showing the flow of energy transformations in a car, starting from the vehicle to driving. So from starting the vehicle to driving. You should have 5 different types of energy, okay? And I want you to explain the transformations that exist between those types of energy. So in your notes, this will just be at the very bottom of your notes, I would like you to draw a flow map that shows the energy transformations in a car from when you start that for you guys tomorrow. All right.